Hi, everybody. I'm Bryan Norcross along with Luke Dorris. This is podcast number 16 of Hurricane Season 2021 and podcast number 72 in our series, and probably the last podcast of 2021 unless something unexpected happens. So, Luke, it's looking a lot like we're finished with at least purely tropical systems this year.
Looks that way. If you're a betting man, that's the way that you would go. I mean, maybe Wanda tries to do something, but even the odds for that are looking less and less.
But that wouldn't be
That wouldn't
tropical.
even be a pure tropical.
That wouldn't be
It'd be
tropical. Okay, yeah, it'd be a hybrid system. So today we have a special podcast. We're honored to have Dr. Louis Uccellini, the director of the National Weather Service, here with us, because Louis has been instrumental in building the National Weather Service that we have in the United States today, the system for interacting with emergency managers, upgrading computer modeling, understanding and ranking winter storms, and so much more. I don't think anybody has been more instrumental in the worldwide weather enterprise in the U.S. than Dr. Uccellini. On our last podcast here of 2021, there's nobody better or more appropriate to have with us because Louis is going to retire at the end of 2021, technically January 1st, 2022, after some 43 years in public service and over 50 years in meteorology. Louis has been at the heart of meteorology and the worldwide weather enterprise for decades, and we'll talk to him about his career and what's ahead for the Weather Service here in just a few minutes. We're recording this podcast on Thursday, October 28th, 2021. If you're listening at some point in the future, for the latest weather in South Florida, of course, tune into Channel 10. And Local10.com has all of the Local 10 newscasts streamed live for you there, live and free, so you can get them at any time, Local10.com. And also, the Max Tracker Hurricane app has the latest tropical information, if there is any more tropical information this year. And, of course, the Local 10 Weather Authority app has all the current weather information all year long. So, right now in the tropics, you mentioned, Luke, the potential Wanda. It started out as a nor'easter, which is what we call non-tropical systems right near the coast that make the winds come from the northeast, especially on the northeastern U.S. coast. And then it moved out to sea, so now it's a wintertime type low-pressure system out there that might dip south over somewhat warmer water, has a chance maybe of forming a tropical core. You said doesn't look like a high chance.
Yeah, and the water there is not that warm, right? I mean, we're talking upper 70s from the analysis that I could see. So it's pretty marginal. The chances from the Hurricane Center of that happening, of it gaining some of its energy from the ocean and being somewhat tropical, have gotten lower and lower and lower. But as you look at the water analysis up there, once it gets away from kind of the core of the Gulf Stream, I mean, we're talking farther away from the coast. We're in the North Atlantic now. There's a really sharp shelf there where the water gets cold fast. You drop down a little south of that, but still, is that warm enough, do you think? I guess the Hurricane Center is thinking so.
Well, it's in the 70s, and if the air aloft is cold enough, then the difference between the air aloft and even, normally, nominally, we say 80 degrees is what the water should be for tropical development. But that's assuming an average tropical atmospheric temperature,
Sure.
where it's the contrast that makes the air rise that can get a tropical aspect of the system. So if the air aloft is cold enough, over top of that marginally warm water, that can be sufficient. So no doubt that's what the thinking is, but they only have 30% on it, so obviously this is hugging the line on whether it's adequate or not. We'll see. If you look at the upper air pattern, I mean, it looks like hurricane season is over. There's a strong subtropical jet kind of comes across the Gulf and Florida and a good part of the Caribbean and out into the Atlantic. Now, it does oscillate up and down, back and forth a little bit, but really doesn't look like it's going to, change into some sort of tropically supportive pattern.
Yeah, you get these brief breaks where the Southern Caribbean is favorable, but it doesn't last because it keeps, getting these jets that come by. But the water's warm enough there. There aren't really disturbances, though. I was looking, this is a couple days ago, and everything kind of favors the Pacific side. More than the Atlantic side, you see kind of a real weak little or moderate sized area of rotation there. Is there somewhat of a weak Central American gyre that's trying to get going there, and then it just favors more of the Pacific side, or is that just normal disturbances that are kicking west into the Pacific?
Well, they're always just by the nature of the shape of the coastline and where it is in the ITCZ. They're the intertropical convergence zone. There does want to be rotation around Central America, and so what happens later in the year like this? If you think about it, you get a dip and the jet stream comes down. Well, that kind of enhances and a high pressure system aloft that if that aligns with the Southern Caribbean and the Central American gyre, you can get low pressure developing in the Southern Caribbean. So that's what happened last year, twice in a huge way. And it quite often happens. It sort of happened with Michael later in the year, right? You get this general low pressure developing down there, then a dip in the jet stream comes down and scoops it north. This year, the model shows some low pressure developing down there, but not a continuous enough and favorable enough pattern to keep it going. Like you said, when you get this favorable bubble of air over top of the Southern Caribbean, it kind of moves on this year, where last year it just sat there. So I think that is what's going on this year. So I think the odds are very low that we're going to get anything more, especially affecting Florida, the U.S., the Bahamas, at our latitude. Never can rule out something spinning up somewhere on the fringes. Even into December, you can have a storm that forms by an odd confluence of events, but normally those kind of storms don't affect Florida or the U.S. in any kind of significant way.
Sure, that'd be a strong front somewhere way out over sea, right? That
Right.
would spin something up. That's what you'd be telling. Wasn't there one in January one year?
Yeah. They've occurred and crossed the new year, as a matter of fact. That happens on occasion. Hopefully it's not going to happen. Hopefully we're all done for the year. We're kind of counting on that. All right, so let's bring in the current, soon-to-be retired director of the National Hurricane Center, Dr. Louis Uccellini. Hi, Louis. Welcome to our last podcast of the 2021 hurricane season.
Oh, Brian, how are you doing?
Yeah, we're doing great. So,
That's great. Yeah.
Louis,
I was just going to say one thing. 2021 is about a bit over a year since we did the last podcast, and we were in a COVID posture then. Exactly. I never thought, we'd be in it this long. So I'm really amazed that we're able to do this kind of thing, in the remote setting that we're in. And I thank you for doing this.
Yeah, well, and we have much better technology. It's amazing. COVID has really improved how we can do all this stuff, which I think will change the future in many ways. Louis, let me say that you and I are of a similar age. So I've been around to see the transformative work that you've done at the National Weather Service over more than 30 years that I've been around. So congratulations, first of all, on many levels. And it's going to feel different without you at the helm. But I know you've built a great team there.
Well, thank you. Thank you. And we do have a great team, and I'm confident that they've been in a sense leading the way for the past several years. Actually, taking the strategic goals that we've laid out and making it work. And it really has been an incredible team to work with, and complete confidence that they'll continue making progress.
Yeah, I know at the conferences that you and I have been at, where you've had some of your senior folks there speak, they're all extremely impressive. I know the Weather Service will be in good hands. So as long as I've known you, you've been an administrator, whether it was at NSEP, responsible for science and modeling, which we'll talk about a little bit later, or running the whole National Weather Service. So with all that administrating, do you still get any time to look at the details of day-to-day meteorology, like this somewhat unusual nor'easter that formed off the northeast coast just a couple of days ago?
Yes, I do. I've always made room for, in fact, I do my own weather brief in the morning, even before I get the the National Weather Service stand-up that we have at 7:45 Eastern Time every morning, where we review in 15 to 20, sometimes 25 minutes, every system status, the important weather features that happened the day before, and if there are any issues that are still that we're still working with those systems, and then onto the forecast for this day and beyond. There are every other day, every twice a week, we have the Climate Prediction Center on for the week 2 outlook, and so yeah, I'm always have my finger on the pulse with respect to the weather and
So
water and everything
yeah,
else we do.
that's good to know. The guy at the top still right in the middle of it and keeping his eye on everything. But when you were back at the University of Wisconsin and you were getting your master's and your PhD, did you imagine yourself back then as becoming an administrator, let alone running the entire National Weather Service, or is that something that evolved over time?
Well, no, it evolved over time. I when I was at the University of Wisconsin, even as a undergraduate, I didn't really have a full appreciation of my abilities in the research world. Even though I was doing research as an undergraduate and started impressing the professors in what I was doing, but I had literally no thought about going to graduate school until the end of my junior year, where Professor Charlie Anderson tapped me on the shoulder and asked me what I wanted to do. And I says, well, maybe I'll go in the Weather Service and become a forecaster. And he said, literally, like hell you will. You're going to be a researcher. I got a research assistantship, all for you. Don't apply anyplace else. So then as I really got into it, I was doing gravity wave work research then, and I did that for my master's, and then I switched over to Don Johnson and did my PhD in jet streaks. I was already publishing papers, and then of course I went to NASA Goddard Space Flight Center as into the research world, and really enjoyed it. So even that, I even as I was working in NASA, I got involved in administration under Joanne Simpson, running the mesoscale analysis and modeling section. But I didn't really know where I would wind up even after that until I started reading about the modernization of the National Weather Service and saw Ron McPherson give a briefing on it. And I just wanted to join the Weather Service to be part of the modernization. That was it.
Isn't it remarkable? Oh, I'm sorry. Go ahead.
No, I was just so there are these capricious moments in your career that you look back on and say, oh yeah, that was the moment I decided to do that. But even many of these moments are a tap on the shoulder or a person coming into your life as your boss or whatever that helps set a path. And here I am. So.
Yeah. Isn't it remarkable how somebody can change the trajectory of your life like that? I mean, you had this guy that told you that, like hell you will, and lo and behold, instead of being a forecaster at the Weather Service, you have the life that you've lived. It's incredible the impact that people can have. And
yeah, and I think that's a common story really in many of people's career. There's a moment, there's a person, there's a mentor that really does make a difference, and that's what I tell students. What you have to be ready for is when those moments come to you, and that usually it's because you're accomplishing things. So and that's something that I take pride in. That whether I was at the university working, when I started something, I got it done. I went to Goddard Space Flight Center. There was a whole bunch of things I got involved in. We published. We analyzed the first geostationary sounder, which was the VISR atmospheric sounder. I was named the VAS demonstration scientist by Dave Atlas, and published a lot of papers with respect to geostationary sounding for the first. So that's the mantra I try to tell students. You have a vision, you have a plan, but you got to follow through, and then take advantage and be ready when something like that happens, and or you attend a conference and you see the modernization and you say, geez, I'd really like to be part of that, right?
Hmm.
Um, you know, those kinds of moments come and go, and you have to be there to be able to take advantage of them when they happen.
Yeah, sage advice. I'd say that's all very true. Meteorologists, though, they will, especially those that are interested in storms, they'll know your name from the scale that ranks how impactful northeastern snowstorms are. So, what was the motivation with that work, and how is it different than other scales that rank storms that we're more familiar with, say the Fujita scale or the Saffir-Simpson scale? Tell us a little bit about that.
Well, we Paul Cosin is the one who actually came up with the scale. You know, he was the lead author on the Northeast Snowstorm monographs that we did. I was the second author. Um, what we were doing, we worked 10 years on the two volume book together. I mean, it was just the back and forth on that over a 10-year period to get the book out. At about 7 years into that, we were getting questions like, why are you picking the 32 storms that you've picked to follow as extreme events, right? And that was a good question because we grew up, both Paul and I grew up on Long Island. We didn't know each other in high school. I didn't know Paul until we walked in my office at Goddard Space Flight Center as the contractor, right? Uh, so that was a really good question. And I happened to note to Paul that it'd be good if we could quantify these storms somehow. And he came back with the scale, with the NESA's, Northeast Snowstorm Impact Scale. And the I is really important. And that was something we talked about, is that if we do quantify these storms that people can point to, besides having the memory, aspect, everybody remembers the big storm that they lived through. Um, how do we quantify it from the point of an impact scale? So what he did was he mapped the snowfall that we had with these storms over the population density. Okay, so how you measure impact of a storm, it could be the wind, it could be the temperature. You get a lot of impact with 1 inch of snow if it's 25 degrees, and that freezes instantly on the road, right? We saw
Yeah.
that in Atlanta, for
Atlanta,
example.
yeah, the snow
Right.
jam in Atlanta,
That's
2013.
right.
Yes.
That's
Yeah.
right. So the thing is, what we were focused on when all was said and done was the snowfall in the cities, where the impact. If you get 35 inches of snow on the top of a mountain, it's really nice, and it might be impactful for the ski resort, but from a population point of view, they might not even notice it. So we did that, and lo and behold, it really was working for us in terms of differentiating the really big storms versus the moderate storms versus the inland storms, okay, where you can get 30, 40 inches of snow, but the population density is less, and the impact doesn't last as long. And we were seeing this in economic statistics and things like that as we were looking into it. So that was the birth of the NESAS, was for the total event from wherever that storm started to maximized over the Northeast U.S. What was the snowfall, and what was what population density did it affect? Because generally the societal impact will be magnified by big population density, right? I mean, more
Right.
people that have to stay home, the bigger the impact is on the economy, things like that.
And
So
more
that's how
memorable.
that scale came about.
Yeah. And Paul Cosin, of course, is a renowned forecaster, winter forecaster, and went on to work at the Weather Channel for a while, where I knew Paul, and
Yeah.
he's
Yeah.
accomplished a lot in his
And
years.
and he has like all the folks that you get interested in particular weather types, you have a sixth sense for it.
Hmm.
And so Paul and I both had that. He came up with the idea for a monograph. He was just analyzing all these cases and what am I going to do with this? And I said, let's write it up. I said, and he said, who would be interested in it? I said, well, about 10,000, weather fanatics up and down the East Coast. So
Exactly.
the thing is, yeah, it was really great piece of work. I really felt proud to be part of it. And, it started with the smaller book, the first book, what's called the White Book, and got a letter from Holgren, who was the executive director of AMS at the time, says, we need an update to that White Book, because they published the first printing, published the second printing, got it, actually sold out. And we said, okay, take a couple of years. Took 10 years to do the 2-volume set. So anyway,
Well, you got busy,
it's really nice. It's
Yeah,
really nice.
It really is. Well, so let me take you back to one of those storms. As I recall, at the March 1993 so-called storm of the century ranks near at the top of your list of impactful historical storms, right? It was an incredibly intense, giant storm that tracked from the Gulf, where it did significant damage in North Florida. I was on TV in Miami that first morning because of an associated front that produced a dozen tornadoes or so in Florida, including in South Florida. I also recall that the computer model forecasts for that system were very good, which kind of surprised us because that did not always happen back then. What do you remember about that 1993 storm?
Well, here's we called it. They wanted to call it the storm of the century back in 1993, and I reminded folks that we're not at the end of the century yet. We got to be careful. Right. But it was a historical storm, not only from the magnitude of the event and its impact. Mm-hmm. Okay. But the forecast process for the first time was recognized as you can really start a forecast at 5 days and work it towards the event, and it actually happened. How did you do that? That's the question we were getting after that storm. Okay.
Yeah.
So let me just remind you that from a modeling point of view, everybody I think recognizes that models were introduced operationally in the late 50s and early 60s. The first global model, and with high resolution and improved physics, wasn't operationalized until the mid 1980s. Mm-hmm. And the first
was that the
models,
AVN? Was that the AVN?
That was the MRF, and then
MRF,
the aviation, the medium range forecast model, and then the aviation version of it that was run early. It was run out. You got the output out to 72 hours. The MRF actually produced output out to day 10. Because the 6 to 10 day forecast that the Climate Analysis Center at the time relied on for their extended forecast for agriculture.
Well, and that's what became the GFS essentially, right? This is the
so we just merged all that because there were people who said, "Well, we don't use the AVN because that's done for aviation," and I thought, okay, we got to do something about that. We'll just call it the Global Forecast System,
and then how it's
applied. Right, exactly. So the thing is, it wasn't until the late 1980s and early 1990s, if you follow the papers that were written by Fred Sanders and then Rich Grum, they were tracking the progress of our ability to predict storms. And in the 80s, in the mid 1980s, before the NGM was operationalized, and then the MRF and the AVN was operationalized and then improved with higher resolution, better physics, better data assimilation. There was a lack of predictability, especially along the East Coast of the United States, even beyond day 2. Mm-hmm. People didn't trust the forecast for cyclogenesis along the East Coast beyond day 2. So it was about 1990, 1991, that you saw this dramatic difference in the reviews being written by Fred Sanders in his papers. He had a sequence of papers that were being published tracking the performance of the models, and I covered this in the Sanders monograph that the AMS created for the special conference they had in his name. I kind of followed this, right, because this was something he did that really kept the modelers honest and reflected on how the forecasters were actually using the models in a very accurate way. Rich Grum started picking that up as well as Fred started tailing off on his, what I called report cards on the models. And it was in that early 90s, you start seeing in the Grum papers that, we're seeing skill at day 3. And in fact, if the aviation was still called the aviation at the time, is predicting a cyclone at day 3, the chances are now it's gonna happen. Okay. We started seeing the prediction of secondary cyclogenesis. Now remember, there were papers being written in the mid 70s that we should give up trying to predict extreme cyclogenesis and secondary cyclogenesis. That it was folly. That these are like a burst of turbulence. There were actually there was papers published in a bulletin, is sort of that we should stop trying to do this.
You're talking
By the
about
time we got
secondary. When you say secondary cyclogenesis, you mean off the East Coast,
off the East Coast,
when you're talking about
even out in the
storms.
middle, yeah, and even out in the middle of the ocean, some of these storms develop as secondary and then
Right.
tertiary storms because they go through their entire cycle of rapid development and then decay, as it collapses in, and then there's a secondary storm that develops. So even there, so the point is, we were seeing evidence that the forecasts were getting more reliable for extreme cyclogenesis. So you get to 1993 in March, and we've now extended the forecast, right, with the MRF out to day 10. And I remember coming in on Monday, and now I'm the chief of the Meteorological Operations Division. That's what I came into the Weather Service as, the chief of that division, the largest forecast office in the National Weather Service, part of NMC. And they have a medium range forecast now up to day 5. And they've been seeing signals that would suggest that by the end of the week, there's going to be a big storm off the East Coast. And in fact, there was a series of runs that were really nailing that it would be a really big March event. It would be equivalent to any event that we've ever seen on the coast. We saw that as early as that Monday, and by Tuesday, the forecasters were actually forecasting that. Of course, smoothing out the isobars on the maps as they did, but noting in their discussions, the medium range discussions, which everybody reads, right, that this could be a really big event. Now, what's interesting in this event is I get my chance here to give 3 cheers for the American model. The MRF was putting it right up the coast. Mm-hmm. The UK Met had it inland, had a big rainstorm basically right up the coast, and the European Center had it out to sea. Just saying, okay.
Yeah. Although we couldn't see all those models back then.
I know, but those were written in the discussions.
Yes, they were.
Okay?
Yes, they were.
And we actually we have a chapter in volume 1 of the book, and I've got that open. There are some of the figures that point to those forecasts. Okay, and the thing is, it was really a difficult forecast because of that. Because right all the way back, if the forecasters had different models, if other centers gave us access to their models, they looked at them all. Mm-hmm. It wasn't like one model versus the other. They became very good at understanding the biases in the models. Okay.
Sort of like mental ensembling, right?
They were doing right before we were doing the actual ensembles, which was about operationalized within 10 years after that. They did that mentally. They were really and the verification. We all kept verification, very strict verification statistics in MOD. Dave Olson was the branch chief. Was a firm believer in that. Was very careful in sustaining the statistics. So the fact that the MRF was like right up between the European and they went with that. Mm-hmm. So by Thursday, there was really no turning back. Yeah. In those days, we didn't have the probabilistic stuff we've got now. We didn't have the ensembles to help guide us towards that kind of solution. And Friday we were doing interviews. I did an interview on CBS that was really pointing to this. And by that time, when it was winding up on the evening news, that's when it was digging a hole in the ground, in the Gulf.
In the Gulf, yeah.
In the Gulf, I think it was the deepest pressure for a non-tropical storm south of the Louisiana, Mississippi, Alabama, and Florida coastline. Okay, it really deepened tremendously there. The models didn't get that. The models got the development off the southeast coast. So that's one of the weaknesses we point to in this case, right? There was still a weakness here.
Yeah, so it didn't get the big storm surge. It didn't get the big storm surge.
It didn't get the surge.
In Franklin County in Florida, or Taylor County in Florida up there.
That's right. And 14, what was it? 14 people were killed in that surge.
Something, yeah.
Wow.
Yeah. And it didn't get the front ripping through Florida into Cuba. Cuba's that frontal passage in Cuba wiped out. I forget the percentage of its sugarcane crop, but it was a significant percentage of its sugarcane crop, right? But it did. By that time, people said, "Hey, there's a storm. They're getting heavy snow in Alabama." It was very clear that they would get very heavy snow in Appalachians. States declared, this is the first time that states declared a state of emergency before the first flake of snow was falling. So there were roads already being closed, in Western Virginia, up towards through Pennsylvania, and the thruway in New York State that was going to be affected by this. States were already deciding to close these roads. This is the first time.
Yeah, it was a monumental storm. I mean, it was so well advertised. I remember it being really well advertised. And we were sitting in Miami thinking, okay, this is a northern problem. And then that cold front is coming down the state. And I ran into the TV station early that Saturday morning, I think it was. It was over the weekend, I remember, when the tornadoes were popping off in Central Florida and heading for South Florida. And we had a few while I was on that morning. But it went screaming through.
The thing is, it's really the first time that I saw people taking the forecast this seriously. Mm-hmm. Now, I know in the hurricane world, that's probably not exactly true because, people visualized, Mm-hmm. But there were decisions being made for this storm before it even developed. I remember it in the Friday morning that Secretary Brown got briefed at he was the Secretary of Commerce. He got briefed on this storm and how impactful it was going to be. Mm-hmm. And Paul did part of the briefing, and we were showing him how the models predicted this storm and where it was going to go and all that. And then they showed him the radar and the satellite. And he goes up to he goes, "Where's the storm?"
Secretary Ron Brown.
Friday morning, there was no silver object on the satellite, right? Mm-hmm. There was no hurricane signal out there that was moving towards the coast. Right. There was these clouds that were shifting down, with how these troughs were coming together. You saw the cirrus, but there was nothing that said, "There's the storm." There was no storm, right? And on Friday morning. And he said, "This thing's going to develop between now and tomorrow?" And it was like, "Yeah." And he says, "You're sure about that?" I said, "Well, this is the confidence level." So that's why I want to come back to the decision part, that people made decisions and the storm wasn't there yet. It was like, this was the awe of this storm.
Yeah,
right?
This is what made me, it really, having lived through Hurricane Andrew when the models were challenged by that, and then just the next year to have this storm be so well forecast gave me this renewed confidence in meteorology. I mean, I'm not sure that was true of many other people, and maybe even, people at the National Weather Service in Washington, really to believe.
We were nervous about this. And, one of the things that it shouldn't be a secret, but because it was written up in the discussions, When the AVN came out, the 0Z AVN came out for the Saturday, for the Saturday morning. So now we're in showtime. The next 12 to 24 hours, we're going to get hit. That AVN shifted about 50 miles inland. So I got a phone call from the forecaster on duty at the time, because I asked them to. I said, "So when the new models come out, give me a call." And they were coming out at 10, 11 o'clock. In those days, no internet, so you had to wait for the post-processing. So it came out fairly late, 11:30. And he said, "We got a problem, Louis." And he said, new AVN is in, and it's got the storm tracking inland. It could turn over to rain here. This is DC. So I said, "What about the Appalachians?" He says there's some indications that this thing could go even further west than DC, the rain snow line. So I said, "My God." So then he called me up. The NGM comes in. They're looking at the NGM and comparing with the AVN and seeing differences, in the way the AVN was handling it. And so they were a bit more relaxed. I got to tell you, when I woke up at 4:30 that morning, I only got about 3 hours sleep. You didn't have to put the light on out in the backyard to see the snow coming down. So, I go out there, there's already 5 inches. It's snowing like, it's like, oh, whew,
Exactly.
So the point is, there was more forecast uncertainty in there, but the magnitude of the storm, so there was uncertainty with that rain snow line, and we got, you get caught on that even today. You got to be real careful how you step up to these systems because of the real mesoscale details associated with that rain snow line. But the point is, it's really the first storm, and I'll say this, it was the first storm that got the public's attention in terms of how did we do that 5 days in advance? How did we sustain that when the storm didn't even develop to 18 hours before all those impacts were, as you advertised, actually happened? And that was the first attention brought to the models.
Yep.
As part of the forecast process.
Yeah, that's what I remember. Luke?
Yeah, I wonder if how much of that was the response. Bryan talks a lot about disruption, or the response was to the message that you guys were putting out. Disruption. It was different than normal. You're on, network television talking about it, and it's not the normal type of weather forecast that even back then people were used to. And if that is really why people took it so seriously, just looking back, that was a time when people didn't trust the 5-day forecast like you're talking about. It
Right.
went out a couple days.
Well, the people focused on this because it worked. I mean, one of the things that we wrote in the monograph was and included was the front page of the Boston Herald, and that was on the Saturday morning, and it says "Brace yourself." And they got a little cookbook here of all the things that were canceled, including the St. Patrick's Day parade. Now, think about it in Boston.
Yeah, exactly.
If they cancel that parade and zero happened, okay.
Yeah.
Now, right along the coast, the city's got a lot of snow, but then they got a lot of sleet on top of it, and some of the coastal areas changed over to a brief period of rain. Then it froze over again with the cold air. I mean, this was a mean storm. There was a ship sank. A container ship went out of Nova Scotia and sailed right into this because they didn't. I don't know what they were thinking. Back then, they didn't. The ship captain made a decision based on what they saw over the next couple of days. Boom, they were out. We lost the ship at sea.
Oh my gosh!
All right, with this storm, 30-something lives were lost with that. A real tragedy. So this was a rough storm up and down the East Coast, and all the decision makers were saying, thank God we made the decision to close the roads, and because we saved lives. There were less people's lives at risk because of that. So it was really a tremendous storm. The MRF saved the day, kind of thing for the 5, 4, 3, 2, 1 day forecast, because it really did take a while for the European Center and UK Met to come into an agreement that this was going to be closer to the coast. And I can tell you that the European Center, the 90s was the decade that they really locked in the improvements in their model. We didn't in the 90s because we never got the computing upgrades for the whole decade, which is where we fell behind. So by the end of the 90s, people were looking more and more towards the European center model versus ours.
Hmm.
And I took over NCEP in 1999, and that was, it was really bad. It was a bad situation in not being able to upgrade our models on the computers that we had since the early 1990s. Okay, so this was sort of our day in the sun,
Yeah.
so to speak, and we're still working now to catch up
Okay.
on them. But for this case, for this country, it brought attention to the new forecast process of global observations, numerical models, post processing of those models in a way that changed. We knew it was changing the forecast process. The American public discovered that these models were a fundamental part of it, and the media discovered it, and they've never let it go from this point on, as far as I'm concerned.
Okay, so I want to get back to you now, and you touched on this at the beginning of the podcast. You're talking about NASA. So before you worked at NOAA and the National Weather Service, you worked there at NASA, but that was a meteorology job, wasn't it? I mean, how do NOAA and NASA work together and divide the labor, so to speak? Tell us a little bit about that part.
Well, yeah. So NASA, in the night, I joined NASA Goddard Space Flight Center in 1978 when Dave Atlas created the Goddard Laboratory for Atmospheric Sciences, and the idea was NASA was going through a transformation from going to the moon versus looking out towards space. There was a definite change of looking back towards Earth, okay, and what these satellite measurements could mean in terms of assessing the changes in the atmosphere and the oceans and et cetera, but measuring the atmosphere in terms of radiance measurements that would allow you to derive temperature profiles, for example, moisture profiles, winds. Okay. Well, guess what? Numerical models for weather prediction uses, right? Are those types of measuring systems, but they're not direct measurements. You derive layered temperatures from the radiance, upwelling radiance. So that became an interest to the people in NASA and to those who thought that they could influence the models. And don't forget, we had the Global Atmospheric Research Program that started really under the Kennedy. We're going to the moon speech that everybody knows about. That John F. Kennedy
1961.
gave.
Yeah. Hmm.
Yeah. Well, guess what? The last 4 minutes of that speech is. The useful, peaceful use of satellite data, space data, for the public good. And one of the things mentioned in that speech is for weather forecasting, because there were people in the research community, Sumi one of them, but others as well, that were already seeing that we could use the satellite data for initiating numerical models, which were spinning up at the same time, right? So, so NASA decided to have this kind of laboratory, and I was at University of Wisconsin, where Sumi operated from. I did my postdoc at the Space Science and Engineering Center for a year after that, after I got my PhD, and thought, this is new. Um, let's give it a shot, right? And it turns out it was an amazing experience working for NASA for 11 years, almost 11 years. Um, I mean, to have to watch how they operate as a team. That's where, everything is a team there. Everything. Brilliant people work as a team. Um, to be on the front end of a laboratory and be able to hire new people in, and then to have Joanne Simpson come in to lead the severe storm branch where I was, and her first interview with me, because I was there about a year before her, and I wasn't sure, will this work out? I was going to give it 3 years. First question she asked me was, "Are you going to stay? I've heard a lot about you. Are you going to stay?" This is Joanne Simpson asking me. I was asking her, "Are you going to come? Right? I mean, you going to come here?"
So this is
'Cause-
for folks that don't know. This is Bob Simpson, who is the renowned co-author of the Saffir-Simpson scale, and his wife, who was a renowned scientist in and of herself.
right.
Yeah.
And the first woman in the United States to get a PhD in meteorology.
Is that
Right.
right? I didn't know that.
Yes, the
Yes, I mean
first woman. And
she was
there's a
something for
book.
sure.
There are books being written about her. There's already a book written about her that's just been published. Yeah, so we certainly knew about her, and when she came in, uh, it was great. She gave us, the whole strategic. You start with a strategic plan, a vision plan, and then follow through. And here are 6, hiring slots. Go out and hire the best and the brightest. There's Dan Kaiser and Steve Koch and Svigal Chen and Ralph Peterson and just goes on. And then we brought Paul Cosin on as a civil servant, and it was just a wonderful experience for me. And when you talk about manage, that's where I basically, this is my first management experience. And building something that the mesoscale analysis and modeling section did not exist until Joanne and got me and Bob Adler and Fritz Hassler and others. We wrote that strategic plan, and then this was the component that she says, "Okay, you're in charge." And you know, that was just a phenomenal experience for me. And we published these, President's Day storm papers and everything. It was all meteorology because we were using satellite data in those studies in ways that hadn't been used before, whether it was for models or to do synoptic analysis with numerical models and the data that we had, because the satellite data was high resolution, really gave you insights into what was going on. So we made that work up through the late 80s. And then when the modernization was emerging, and I was always interested in research to operation, I saw that. I said, I want to give that a shot. I'd like to be part of that. And that's what brought me to the National Weather Service.
It's interesting to hear you describe the model, or the satellite imagery from the 70s and 80s, because I know what we have today, and I go back and I see satellite imagery from the 70s or 80s, and I'm like, how did they even use that? So it seemed like it was fairly primitive technology, but when you were in that time, did it feel like it was cutting edge back then, or were you thinking, we just need a little more scientific understanding or development to have a better understanding of the environment?
Oh, it was cutting edge because at the same time that we were doing the imagery, people were using the radiance information from the low Earth orbiting to be able to show what those signatures actually meant from a temperature perspective and moisture perspective. Seeing the 6.7 channel for the first time was like seeing the atmosphere as the fluid that it is, because you were seeing areas that had moisture in them, but not clouds. So when you saw those in motion, it was like the atmosphere was this fluid.
So today we call that the water vapor.
The water
channel.
vapor channel, right? And then you saw boundaries that you didn't see in clouds. And lo and behold, those thunderstorm systems you thought were random, they're right along that boundary. Yeah, some of them's up here and some of them's down there, but they're right along this boundary that was pre-existing. And you start seeing how all these different scales were working. I mean, we couldn't get enough of it. But we always pointed to improvements in resolution, improvements in vertical and horizontal, the temporal resolution. And keep in mind, this imagery wasn't on TV until Terry Kelly came along and did Weather Central out there in Wisconsin and used the Mercatus software and the concepts of that to make it directly applicable on a TV.
Yeah, about
And that's what
1980-ish, right?
Yeah, in the 80s.
Yeah.
Right. So then now the general public is saying, we want to see more of that, right? And it's all that, if you didn't have that, Brian, on your back then, you were out of business, right? So the thing is, and then the radars came along with the high resolution. I mean, after I saw the first couple in XRAD, I thought, how did we do this? Snow forecasting and severe weather forecasting, for the real short time frame. how do we do that without this radar? Because the other radars didn't give you this kind of detail. So each step of the way is an aha moment. But
Mm.
think about the work and the foresight that the researchers had back in the 80s for NextRad, back in the 80s for Goes Next, okay? And then when they get into Goes Next, the Goes R series, right? We want 30-second resolution in that image. We want that advanced baseline imager to build off of what we've learned from the lower Earth orbiting satellites in those channels, right? And my God,
Goes
we
are
can
what
do
we
now.
have today. Yeah, the goes are that we
Yeah.
have
So
today. Yeah. So,
yeah.
so Louis, you talked about the development of the models, and I just to put a fine point on that, you've been as responsible as anyone for the tremendous expansion in computer power that the U.S. has deployed toward making better forecasts with the models, and the improvements have been remarkable. But to what degree is the science better now? Or is it really that we understood the science pretty well 30 or 40 years ago, and the modern computers just allow us to do more calculations, and the models are simply, they just better reflect the atmosphere?
Well, it was interesting when Dan Kaiser and I started. Dan was involved with one of the papers on the President's Day storm on the paper 2, where we had this tropopause fold prior to the development of the cyclone. You got to understand that tropopause folds, stratospheric extrusions, were thought of happening in a way that corresponded to when the cyclone was developing, so that there was not this before the cyclone, you had a tropopause. So the President's Day storm case allowed us to really diagnose that system and show that the tropopause fold in the central U.S. came, and then it descended towards the East Coast, and the rapid development phase happened with the co-location. We used the ozone data from the total ozone mapping system to show that.
Wow.
And
So is this
a lot of things.
1978? So to put, is this the
Yeah, I was in
78 storm?
79 was the
70,
storm.
oh, 79 was the storm, right. Exactly.
Yeah, but we wrote the papers in the 80s and
Right.
showed how all of this was happening. So we were learning what we would, about what we need, that you really do need that frontal, the resolution around the fronts, around the jet streaks, to get these, rapidly developing storms off the coast. Lance Bozart was showing how the boundary layer in that case what had to be important for that rapid spin up, because the air was so cold, the sensible heating had to be preconditioning that atmosphere. And part of the debate when we were writing our papers, I was all focused on the middle and upper troposphere, and Lance's, no, it's all up there in the jets. And Lance was like, well, it's in the boundary layer. And by the time we did the model simulations of these storms with the very high resolution, that we then wrote 2 papers in the late 80s on that, using now the high resolution model data as a database to do the quote unquote synoptic analysis. Mm-hmm. You needed both. You couldn't get it without the boundary layer. You couldn't get it without the jet approaching the ridge in the first part of the storm, and then the tropopause fold coming in the second. Mm. You needed everything, right? Well, what did that do for the operational community? They were still running a 7-level limited fine mesh model with no boundary layer for all intents and purposes. It opened up a bunch of eyes that we've got to get into the higher resolution models. And Bill Bonner, who was then the director of NMC, made it a high priority. Everything had to be, we weren't even using significant level data in the late 1970s. It was all the standard level data was feeding into the models. Okay.
Yes, that was the LFM that you were talking
about.
Yes. Before the NGM, sort of the predecessor of the NGM.
That's right. So these studies started showing. So you get this back and forth, between the modeling community and the research community, and the realization that you needed this high resolution, and then that's what you use for justification to get the bigger computers, right? And then if you want to do 5-day forecast, you better have a global observing system, and that is what generates more interest in satellites, because back in the 80s and 90s, where are you going to get global data from? the satellites. That's it, right? I
Right.
mean, over the ocean especially. So all of these things started coming together, back into the 90s. And with this 93 storm being really a first testament of the abilities when you bring all this together. Um,
Yeah. So bottom line is yes, you need the science and you need the horsepower, and then during your time as leading the National Weather Service, I know that's been a tremendous priority of yours to get the horsepower to run the
we,
U.S.
we
models.
Yeah, but we weren't getting it at the rate that we needed. So people who were complaining about us from the outside had every right to, and pointing to the weaknesses. Because even in 2013, when I took over the Weather Service, and right after Sandy, what happened after Sandy, besides discussion on communicating the storm, was there was a Sandy supplemental.
Exactly.
We got money. Okay, let's deal with the issues. And one of them was we were again lagging the science in terms of our ability to build up the capacity of the computer. So the first thing I argued for as the director of the Weather Service was more computing power. The high-res rapid refresh sat on a research computer for 5 years because I could not fit it on the operational computer.
I remember that this is today we call it the HRRR. Yes.
Yeah, yeah. I couldn't fit it. And it was ready for transition in 2008, 2009 timeframe, and I couldn't
Wow.
do it until 2014.
Wow. So you talked about the GFS and the competition with the Euro, which for a large part of your time, of course, the Euro was ahead, and but now you know what? For hurricanes, we look at the GFS first here. Now the last couple of years. Now
Right.
in the mid latitudes, statistically, the Euro still seems to get the pattern just a little bit better, more consistently better, but it feels like, looking as hurricane guys, it just feels like there's been tremendous advances in the American GFS model. So talk about, how the GFS has fundamentally changed over the last few years and where modeling is going in the U.S.
So a couple of things to keep in mind, and I'll answer your question. It's a really important question, but I want you to understand that the forecasters have access to all the models,
Right. As do we. Yes.
as do you.
Yeah.
And that's really important. And so they've been able to, for the hurricane aspect, been able to relate the differences. And it is true that we've been doing better on the hurricane, and we've been investing money. We've had supplementals after all these big storms. So we've got this hurricane forecast improvement program, and we've got not only the global models, but we now have the HWRF, right, which is really an outstanding model in terms of the track and intensification, to the point where we're talking about storms now before they even develop. And remember, we weren't allowed to do that,
Right.
right? We couldn't even assign a name. We couldn't. So they really have made tremendous progress, and we really have focused on the physics and the dynamics. So we got the new dynamic core. We put in what would, the GF. We're still calling it the GFS because we know all the users have GFS. That's how they access the.
Right.
I've told folks, don't change the name, change the model. Okay?
This is the FV3.
Yeah, so it's the FV3 version. So that's the dynamic core. We've worked on improving the physics. We're continuing that. The next big step is the data assimilation. We've lagged in the data assimilation. And I really want to focus on that because the European Center runs 4D VAR, and they can actually, because they only run one model, they only have one mission, and that's the medium range, right? They actually can ensemble. They can run their initialization 51 times and ensemble the best, most likely initial state, all based on four-dimensional variation. We have a hybrid system. I won't go into details, but it's like a hybrid 4D VAR. It's not what the European Center does. It's what the Canadians do and the like.
So
And
just to be clear, just for folks that don't know 3D VAR, 4D VAR, this is what you do with the raw data to initialize the model to get started right. So
right.
if you process the data well, which is what the 4D VAR does, that the European Center does, you end up with a better starting point. Therefore, you end up with a better ending point quite often. So that's where you're saying that the American model needs to be most improved.
Yeah, so the first step in the whole model system is accessing the observations. All those observations have strengths and weaknesses. So you have to design a system that takes advantage of the strengths and avoids the weaknesses and produces the information on the same grid infrastructure that the model equations are going to operate on, okay, to give you their forecast. So this is the really very important first step in getting that information transferred into the model in a way that the model will actually keep it and work with those strengths and avoid the weaknesses and give you the forecast.
Mm-hmm.
So depending on the sophistication of that data assimilation system could make a big difference in the overall accuracy of your forecast as you step ahead now with these equations, which are initial valued, very complicated physics, dynamics, ground. Now we're taking the impacts of the oceans on it, everything. So that steps it ahead. We're finding that we're pretty convinced that right now our biggest gap is in the data assimilation, and we've never really been able to get into that 4D variational approach that the European Center has, because given the nature of our mission and the range of models we have to run, remember, I got missions from the sun, space weather,
Mm-hmm.
all the way to the top of the ocean, right? And everything in between. I got 11 service areas that we got to run models to,
Mm-hmm.
And the European Center has one thing they got to do: get that medium range forecast out there for the 21 or 22 countries that put money into the ECMWF, and they'll do the forecast. Okay, so we had to make some tough decisions, and I do want to get to this. Back in the late 90s and early 2000s, we could do either ensemble modeling or we could do 4D VAR for data assimilation, but we couldn't do both.
Right. Ensemble modeling in this case is running the model multiple times with slightly different initial conditions, right?
Right. So you get that envelope of solutions, which the TV folks show as the spaghetti charts, or,
Right.
This is where, this is going. And, so those ensembles have become incredibly sophisticated in terms of post-processing for the most likely forecast. So I'm convinced we made the right decision to not only go ensemble models, but to run multi-model ensembles. So this short-range ensemble forecast systems were two models, perturbed different ways. So the GFS, we run an ensemble version. We combine that with the Canadian ensembles to run the North American ensemble forecast system, right? So, and that's what's allowing us today to point to days 5, 6, 7, 8, 9, and 10 with more confidence that there's, hey, this extreme event is being picked up in the ensembles. It was there on day 11. It was there on day 10. Day 9. We got to pay attention to this, okay?
Yeah, this is what allows us to say, well, there's a 40% chance right now, a 50% through the ensembles that we largely
and with longer lead times,
Right.
because the emergency management community needs long lead times if they're going to do an evacuation over a large area. Irma. Think about Irma. The governor of the state of Florida declared a state of emergency 6.5 days before the landfall of Irma in the Keys of Florida. And then it came up the west coast of Florida.
Right.
There was a lot of back and forth for 6 days. Well, the U.S. models along the East Coast and the Euros on the West Coast, and in the next runs they flipped, right?
Right.
The governor just looked at this and said, we would, and we were working with them through impact-based support services, saying it doesn't make any difference. You're going to have the same impacts. You've got the whole state of Florida right up, that's going to be impacted by this heavy rain, surge forecast, winds. They had to start evacuating people from the Keys at day 6 and 5 because they didn't know whether they were going to have to evacuate Miami or Naples, right? Either case, they didn't want anybody coming up from the Keys, right, to log jam whatever evacuation they had to do.
Yeah,
So,
especially tourists and people that were
exactly,
not residents. And all
exactly.
That.
A lot of that forecast confidence in terms of that storm coming in, making a right-hand turn and affecting the whole state of Florida, looking at all the models and the ensembles. So I'm convinced we made the right decision to go ensembles because we needed greater certainty in these extreme events as we were moving forward. But that's one of the tough decisions we had to make under my watch. And today we have a seamless suite of ensemble products from seasonal to sub-seasonal all the way down to the mesoscale for severe weather. We got severe weather outlooks out to day 8 now. Okay. So these kinds of decisions are not easy decisions to make. You got to look at the systems. You got to look where we are with the science internally, how we can rely on the larger community to build up. We decided that the late 90s going into the early part of this century, based on the science that was coming at us from the SAMEX experiment in the middle part of the country, the Thorpex experiment for the whole globe, we needed to go operational ensembles. And that's the decision we made. And it's paid off for these where we are today, as far as I'm concerned.
For sure.
Yeah, speaking of forecasting for hurricanes and using the models, we had Neil Frank on the podcast a couple weeks ago. Of course, he's former director of the National Hurricane Center, legendary figure. And we were talking about how the computer models and the evolution of them, how they were used or they didn't get used much in the late 60s and into the 70s. So what do you remember about the early models and how you used them, how you relied on them? And they've obviously evolved a ton, as you just mentioned.
Well, I'm smiling, and in the 60s and 70s and even the 80s, the only thing you saw on our numerical prediction models was an L. So,
or a big void where it was generally low pressure somewhere over there.
Yeah, well, the thing is, and it might be the L would be there at hour 12 and not there at hour 24, and then be there in hour 36 because you only saw the output every 12 hours, right? You didn't even have, right? So how can you track that? How can you use that, right? Mm-hmm. So, when I was in MOD in the late 80s, they weren't using the models at all in the hurricanes, rightfully so. In 1992, so I got 93 as the storm of the century. 92 is Andrew.
Yes.
Andrew was the first model that the bogus low was used to initialize the global models in the tropics.
The AVN. The AVN had the
AVN.
They forced the low in, and it had the closest to a good forecast. And the AVN was what I used, by the way, to
So Andrew was the very first one.
Right.
Right.
Yeah.
So now Bob Sheets, I can tell you because I became good friends with folks down in the Hurricane Center. I'm still in the beginning of my tenure in the Weather Service. I was treated like, hey, I'm an outside researcher. You still got to, get your wings in the operational community. But, I knew that they didn't use the models for a really good reason. And so back in 90 and 91, I'm in MOD, the Meteorological Operations Division. Yehania Kalney and Steve Lord are running the development division. That's the modeling division. Steve Lord came out of the Hurricane Research Division up to EMC, and one of his main tasks was to be able to initialize the models with an existing hurricane so that the models would keep the signal. Okay. Mm-hmm. Andrew was the first that was put in place for 92 hurricane season. Andrew was the first example. as that storm was approaching Florida, the policy was still not to use the models.
Well, not to
But
use that model because it was experimental, essentially. It was the
it
first
was
time they'd
still an
seen it.
experimental.
Yeah.
You're not using that to make a decision.
Right.
But people were watching that,
Yes,
right?
they were. Yeah.
The L was kept intact, and it moved right towards Miami.
Right.
All right. And it hit Miami. So what happened after that was very interesting because, first of all, tragically, a number of the houses that people lived in, the Hurricane Center was hit, was nearly disabled. We had people up in the MOD as the backup system. It worked. They were there. There were four. So
Yeah, Jerry Gerald, I think, was
Jerry
one of
Gerald was one of them.
Went to Washington.
Yeah, he was one of them.
Right.
And I spent time. I just watched. I watched them all operate. It was really fascinating to watch them up. But he was telling me, he was getting the phone calls, the people's houses that were, significantly damaged, including some of the people that were up there. But he was also telling me why they didn't use the models because, so they were very interested in looking at this. So what happened was the Hurricane Center itself was hit pretty hard, and it was just barely operating.
It's amazing they held it together, actually, because they had no air conditioning. It was
right. So
crazy.
a lot of the stuff was still happening with the four people we had up in Camp Springs.
Right.
So what was the 3-day challenge? Where's Andrew going to go? Because it went right across southern Florida, and it came out of hurricane. And the model was saying, this is going to go just southwest of New Orleans.
Yeah, we were worried for New Orleans. Even
right.
in Miami, dealing with what we were dealing with, everybody was scared for New Orleans.
That's right. So the policy changed. Because right from that time when that storm was going across Florida, and now you've got model data that, don't forget, model data is used to help initialize the next run of the models with the data assimilation working on top of that. It was very consistent in moving that storm just southwest of New Orleans, but of course people were saying it could go anywhere from the panhandle of Florida all the way to Houston or something, right? So, but the more that storm was approaching New Orleans, it was looking like, this model is not bad. So people were using that, and that became the turning point. Of course, there weren't that many storms that year, but there were some real serious discussions after that year. I remember in the spring of '92, there was a couple of things happening. The flooding was starting in the Midwest for those big, flooding. No, I'm sorry, that was in '93 also. There were some things happening in '92 that was keeping our attention. But we all went down.
Iniki happened in '92 as well, didn't it?
Right. And we all went down there. The folks from MOD, me as the division chief, EMC, Jim Halcroft as the deputy director of NMC, and one of the model developers in his day. He was the architect of the LFM, which was the first regional model ever. So he told us we needed to lay out what we thought we could do or not do from a modeling perspective, and then the Hurricane Center had to be working with us and saying, setting the expectations and the limits and what they thought was possible. And we got together in a very serious way to start the whole process of trying to improve the models for forecasts. And I would say that the Andrew and the post-Andrew assessment was the beginning of Hurricane at Landfall, which was the only project that we got approved through the U.S. Weather Research Program. All right.
Really?
And that was because of the work that was done at HRD, working in collaboration with EMC and being able to articulate, why this would be important to get that track forecast right, but what it was possible, the art of the possible from a modeling perspective. So I thought it was just really amazing to be part of that whole sequence, because I became co-chair of the European, I mean, the U.S. Weather Research Program. I became co-chair of that, and we decided, with everybody sitting around the table, if we had to prioritize which one we would go for. We had like 9 different projects to consider. It was hurricane at landfall.
Yeah. Well, if you go back and look at the Hurricane Andrew discussions from the forecasters at the Hurricane Center, you see them increasingly mentioning the AVN. That the AVN keeps saying it's going to go west. The AVN keeps saying it's going to go west, right? Because at that time it was just experimental. They had never seen it before. It didn't come in until the evening. The morning run came in the evening at that time, along with another model called the QLM, which was also not terrible. But they were the ones that they got in the afternoon for the 5 p.m. advisory. Those were the NHC 90 models and like that wanted to take it north. But that AVN wanted to take it west, and just more and more and more they were noticing that as the storm got closer.
Right. So, right. And we had the backup plan in that was the first year for the backup plan, that people would have to leave the Hurricane Center, fly up, and be in MOD. And nobody really wanted to go.
Right.
Bob Sheets wasn't going to pull the plug on anything, rightfully so. But it was that day, the day before, they finally said it is moving west. Mm-hmm. But we started dusting off the plan and calling down, and we had Joe Friday on the phone. That final decision was made at the top of the Weather Service to get 4 people, up. And by that point, Bob Sheets concurred. He had to have an outlet, for getting the information out. By the time they got on the plane and left, it might have been one of the last planes that left before Andrew hit.
Wow. The 36 hours, about 36 hours before Andrew hit, the forecasts were essentially perfect. After that, and the AVN actually contributed to that. And it was heroic what they did at the Hurricane Center to keep it going after that storm, after what they went through there in the kind of northern edge of the eye wall. I mean, it was just, we were on TV with Bob, and then when we lost the microwave dish, it blew off the Hurricane Center. We had a reporter there. We had Bob on the phone, but we also had a reporter in the Hurricane Center. And of course, they were there when the radar fell on the roof and shook the building, and somebody said that was the radar.
Did you know Ken? You knew Ken Haydu. He was down there.
Yeah. I remember the name.
And he wound up later becoming the MIC in Dayton, Dayton, Ohio. But he became a part of the strategic team that I led under Ron McPherson for the creation of NSEP. Because at the time the Hurricane Center was not part of NMC.
Really?
Right. They weren't. They were part of the Weather Service.
Right.
Right,
because they ran their own models, right? The end of the NHC in 90 that was developed by Charlie Newman and people at the Hurricane Center, right?
So neither was the Severe Storm Center, which was the NSSFC. So they reported to the director of the National Weather Service. And so what happened as the modernization proceeded, that's where NSEP was imagined as having all these centers working together, with the modeling center and the what's now NCO, Central Operations, right in the middle of that, right? So I was the actual lead on the strategic planning team, and Ken Haydu was the representative from the Hurricane Center. And then remember, the name changed to the Tropical Prediction Center, and then decided to change it back. But I really got to know Ken, and one of the first things he talked about was being there during Andrew and what they went through. he said they spent some time in the stairwell.
Yeah, they did. Yeah, no, I've read a lot of accounts and knew a lot of people that were
Yeah.
there that night, including Max Mayfield, who
Yeah.
very close to us at WPLG. Yeah.
So the thing is, these kind of big events, we've talked about Andrew and what it meant for the first application. It's crude, right? But Steve Lord was a tropical expert. He worked at HRD. He came into EMC, got tasked to do this. It worked for Andrew. We saw it work for other storms in the tropical area, in the point that it kept the hurricane. You could get the tracks from this, with better, it's like the L's weren't coming and going, they were sustaining themselves, and you could. So that's what started when the U.S. Weather Research Program started in the 90s. Hurricane at landfall became a big deal, and HRD was the main proponent of it.
Yeah, when I wrote my book about Hurricane Andrew, I talked to Steve Lord actually about that. I learned a lot of things about how that early AVN tracker actually worked. So we also talked to Neil Frank about communications. Back in the day, the Weather Bureau, the National Weather Service forecasts and discussions were short and to the point for a lot of reasons, I think, including communications technology. But now we know so much more, and there's so much more information to dispense. So talk about the communications part of forecasting the weather, which really is kind of a separate stage that in your time has evolved. And I know you have focused on that a lot in your time running the National Weather Service. And how do you think it's going to evolve in the future?
Well, you mentioned Neil Franks. When Bob Sheets first visited MOD after I took over and I got introduced to him, here's Louis Uccellini, coming in from NASA Goddard Space Flight Center. He's going to run MOD. And Bob Sheets said to me, he says, I got some advice for you. And he says, if you think your job ends with the forecast, the watch, and the warnings, well, of course, we didn't do watches and warnings from MOD, they did from the Hurricane Center. But he says, if you think your job is over with that, go back to NASA. I swear to God, it's the first thing he said. And the thing is that I'm sure he was making a point in his way, and very proudly so, is that's what they do in the Hurricane Center. Okay, their job wasn't over. They were already working with the emergency management at the state level. Yeah. So,
and the media.
Yeah. Right.
And Bob was fantastic. I mean, Bob was just a hero of
So he understood that. He understood that. And I would say that out of all the service programs, the hurricane program, the service program, was the first to really do that. My interactions with forecasters up to that very first moment was always, our job is to forecast, right? I even heard this when I was in school. What people do with it is their business.
Right. Throw it over the transom, and then it's
throw it over the transom.
That's right. Not our problem.
So the thing is that, but when I lived through Katrina and watched the states getting ready for Katrina with now a better forecast with the cone of uncertainty and all that, and then FEMA holding the coordination calls. I'm not going to go into details here, but Louisiana wasn't ready, even for those calls, much less ready for Katrina. The city of New Orleans was not ready.
Yeah, Max had to beg them to pay attention to the forecast.
That's right. Yeah. But you can't just flip on a switch, 12 hours before. You got to start this part. So that taught me a lesson watching that. First of all, that Florida was ready. It was really amazing watching it because Florida started and Fugate was in Florida. Right. And boom, when FEMA asked them, boom, 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 boom. Don't forget, Katrina already, now they're in a recovery mode because it went over the Keys, right? So as it came into the Gulf, right. It did some damage down. So the point is,
in Miami as well. I mean, we lived through it in Miami. Yeah.
Yeah. So was it going to curve back, or was it going to come this way, or was it going to go into Texas? So they mapped all this stuff, right? Be right. Fugate was like boom, 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 boom. And I can
Well,
tell you
Craig
that
came out of
Alabama,
Andrew, right? I mean, I met Craig during Hurricane Andrew.
yeah, he was ready.
He was
You
ready.
know, he
Yeah.
was ready, right?
He
And
learned the lesson.
he could give you a weather briefing better than probably you and I
Yes.
combined, right?
Yeah, he's an
So the
amazing
thing
guy.
is, you know, they went to all the states, and everybody. I mean, I turned around to my folks uh, in what was still HPC, and just said Louisiana's not ready, you know. But it taught me, first of all, there are differences state to state to state. So how do you make that work? You know, and then that you got to work further out in time, because I started seeing firsthand that 36 hours in advance, 48 hours in advance is not enough time for these folks to get ready to prepare a state. I mean, Craig Fugate was making that point, and what he was doing was starting even days earlier than these FEMA calls, right? So the thing is, I started thinking then, about how do you connect with decision making. And then 2011 happened. And and with snowstorms, forget it. I mean, the idea, we did great in snowstorms in '93 and '96, and then we had a whole series of forecast busts. And so, how do you message into now another growing vision, reaction that, well, you got too many false alarm ratios. How can we have confidence in you? So the ideas started percolating in my head about working with people well ahead of time, so they understood the uncertainty, right? A lot of uncertainty with snow, a lot of uncertainty with forecast tracks of hurricanes. How do you do that? And that's where you started seeing the cone of uncertainty with the hurricane track, for better or for worse. Okay, I'm sure we could spend another
Yes.
hour or so just on that. But the point is, we realized that we got to start communicating. Then 2011 happened, and this was my seminal moment, my internalizing the need for change. Okay, and that was the severe weather outbreaks, because the 2011 April outbreak that creamed Alabama and points north and northeast, it was over a fairly large area, was very similar to the 1974 outbreak that I lived through on the northern edge of it when I was in Madison, Wisconsin. And that was the famous April 3rd and 4th outbreak that Fujita mapped and made his
Right.
name with.
It was the Xenia,
And
Ohio. Wasn't it Xenia, Ohio?
yeah,
Yeah.
Xenia,
Yeah.
Ohio got destroyed
Yeah.
practically,
Yeah. And I
So when
worked
you
that
look at
2011 one with Dr. Forbes. I was at the Weather Channel then. And, that was, I can still
yeah,
picture that tornado coming into Tuscaloosa.
yes, it was just stunning.
Yeah.
And the thing is, the total number of people killed in 1974 was 316. The total number of people killed in 2011 was 314. Kathy Sullivan then tapped me on the shoulder, another tap on the shoulder, in 2011. I'm still the head of NSEP, and she says, "I want you to organize a national conversation, because we declared the modernization a success. Your extended watch and lead times for watches. 2011 was the first time they did an extreme outlook, 36 hours in advance for Alabama. The watches were just fantastic, right? And the dynamic nature of the watches. And then the warnings, we had lead times of average lead time 20 minutes, some lead times up to 45 minutes. What's missing, right? So we had that national conversation, organized it with NSF. Mike Morgan, who's now went back to Wisconsin after his stint in NSF. Um, uh, Dar- Barry and Moore from Oklahoma. So we had the first responders, we had emergency managers, we had social scientists, we had local forecasters, we had national center forecasters, we had administrative. I went in there thinking we had a problem articulating watch warnings. You were hearing confusion about that. I thought, well, maybe we got a problem with watches. We don't have a problem with warnings. We had problems all over the place communicating.
I think you had media.
No,
Was this one of the ones that, I mean, I remember being, you inviting, when you were at NSEP, you inviting us all up there to have these roundtable discussions. I can't remember what year
yes,
that was.
yeah. This was all part of it.
Yeah.
So the thing is, the thing is, it's not that the warnings were great. The problem with the warning, okay, I had a problem. Okay. I thought that if you gave a 45-minute warning on a storm, people would seek shelter. They get
No.
you get more people into shelters, you'd have less deaths,
Yeah.
right?
No.
That's not what people did. 45-minute warning. If their kids were on the other side of town and they did the calculation, I could get to those kids and bring them back to the house 20 minutes. That's what I'm doing, right? Or things like that.
Yeah,
People
they
would
got bored with the warning, so they weren't going to sit in the basement for
right,
that long.
and there
all
were
kind of
people
things.
who were going into shelters and coming out because
Yeah.
I ain't staying in a shelter for 45. They got in there 20 minutes later. They're walking out, and some of these people got killed. Okay, so what the problem is not just communication. Okay, I know you and I have had discussions with respect to Sandy and communicating, right, and how you communicate and all that. Very, very, very difficult, very complex topic. The social scientists were there talking about changing risk assessments, and I was hearing this for the first time. That if you only have 10 minutes to react, your risk assessment is I got to react right now. You got 45 minutes. You're on a phone. You're comparing what other people are saying because you got time to still assess whether this thing's really going to happen.
You go look at the window. There's nothing out there right now that
That's right.
diminishes the warning and so forth.
Exactly. So
Yeah.
people's risk assessment, that process for assessing their own risk, we did not understand. Okay. It wasn't a matter of if the watches were good and the warnings were good. How you communicate action statements, we weren't doing that. Okay. And we've learned a lot from that case, and that was the beginning of at least me. And I already was. I also led the strategic team for Weather Ready Nation, which was actually developed in 2010, going into 2011. That's cemented in my head. With these impact-based decision support services, that's what we needed to do. Okay, so when in 2012 came around, and there was some financial issues and budget issues that vacated the CFO and the director of the Weather Service, and it was because of very complicated structure that nobody understood, quite frankly. I got this job, and the first thing I said to the workforce, I said two things in the all hands meeting. One, we're a science-based service agency. We will operate as a science-based service agency. We'll make decisions based on what the science is telling us. Two, I believe very strongly in vision, plan, follow through. We have a vision and a strategic plan. It's called Building a Weather Ready Nation. It's been on the shelf for a year. Dust it off. That's where we're going. And get to understand that our job does not end with a forecast and warning. Now, that's easy to make those kind of statements, right? I have to tell you, I've been part of strategic plans that haven't been successful.
Yeah.
Because people don't embrace the need for change, and they're not going to embrace this. But people were seeing this. People were seeing it, and they lived it in 2011, right? Going through those cases, the workforce really embraced this, and so 10 years, that's 2013 is when I became the Weather Service Director. Right from the get-go, it was this Weather Ready Nation. We got to deal with the social science. We got to deal with how to communicate uncertainty. That was part of the problem with Sandy. We've got to communicate in a way that people who make decisions on the ground understand what we're saying in terms of those uncertainties. So we got to practice with them. It's not what happens, 5 days before an event and they're seeing you now for the first time. We've got to practice with them all the time so they know we're there for them and we understand their decision process, because we didn't understand their decision process in the ways that we had to. Like in hurricanes, if you're going to evacuate someplace at days 4 and 5, that IDSS has to start at day 10 because they got to see how you're getting to that point at day 5 and 4, right? That they have confidence, even though it's not a perfect forecast. And we know we can't do perfect
Yeah, because
forecasting.
people have to prepare mentally before they pull the
That's right.
string and prepare
That's right.
physically, right?
So this is what we've done in over 10 years. I've gone to every conference, the International Association for Emergency Management. I've gone to every conference there because what we also relearned in this country is that for us meteorologists is that decisions are made at the local levels. For public safety, about 95 to 99%. FEMA's role is to help coordinate, pre-position assets, but the decisions to evacuate, they're made locally.
Exactly.
Okay. So we have to do this across all government levels, federal, state to local, tribal nations, Pacific Island states, native Alaskan communities. They have their government structures, right? So we got to do this across the whole spectrum, and that's what we've been doing. And I think we've been making tremendous progress in all service areas, and that's the lesson. But it started for me the journey. And if Bob Sheet sees this, you can go back and ask Bob if he remembers. But that was the first thing he said to me, and I know that they were doing some of this. They weren't doing it holistically. And a big part of this with the intragovernmental level, you got to do it in a collaborative way within the Weather Service. So the centers and the local offices got to work together. There's got to be one message, right? We got to do it with you. You're a Weather Radio Nation ambassador, right?
Yep.
So the point is that's the chat, right? And chatting with our key partners before, during, and after. Before is really important because you got to see what we're doing. We got to hear what you're doing, so that we can get on this same song page. Because the public, if they're getting, I was looking for my phone here, they're decision makers with this, okay?
Exactly.
And if they're getting different information, they're going to do their own assessment, which they're going to do anyway. But if they're getting different information, they might not react as specifically as they have to, right? So that's where we are today. We have, this Weather Radio Nation has been a big success, I contend. We got collaborative forecast processing. We have chat. We're engaging you, and in the chat, we know we have problems with the dissemination system, but we finally got the plan through to Congress. We got money coming in. We've been very aggressive in addressing the gaps we know we have and what we need to do. And the demand signal is just enormous in these types of distributed computing systems that we're going to be at the budget tables long beyond me leaving the Weather Service, arguing just as much for that kind of infrastructure as we argue for the computing infrastructure doing the models, because we've got to touch the count. We got to get to the county levels where the decisions are made, or the city levels, if we're going to save lives and protect property. So this is what we've learned, and this is what we've been working at over the past 9 years under, my tenure here as the director of the National Weather Service.
Yeah. Well, it's been remarkable, the difference that I've seen in the interaction between the Weather Service and local government, and just the fact that it's a smooth system. People know how to work the system now. It took a while for that to happen, but it has made a tremendous difference to local emergency managers.
And the fact that it's happening and it's really accelerating now is the credit to the workforce. I want to just emphasize it. They embraced this early on. In many ways, when I went to the IEM conference and saw these joint presentations with the emergency manager saying, "Here's my problem," and then the Weather Service guy or gal getting up and saying, "Here's how we address that problem out of our forecast office," and they got the whole timing thing worked together and all that. And I'm just sitting there saying, man,
That's
they have
good.
this. They have this. Mm-hmm. We've done surveys with consulting companies coming in. McKinsey's came in and they do this operational workforce analysis every 2 years, and the trend lines are up on the embrace of IDSS, the embrace of weather ready nation as a strategic outcome. They talk about it at the NWA conference, at the AMS conference, like it's theirs. And it's amazing how they've embraced this, going beyond the forecast and warning, getting out of their comfort zone as a physical scientist, dealing with the social science issues now in a way that they're hearing from their local decision makers. This is the way it's got to operate. They're responding to that. So it's just really been phenomenal to see the transformation. And at this point, in a very, very real way, they are leading the way.
Yeah.
In making this work.
It is. It is. I mean, we see it. We see it work at a totally different way now than even maybe 5 years ago. So Neil Frank really started the changed the paradigm of communications. Then Bob Sheets took it to an entirely different level, and it's great to know that legacy has continued with you. So Louis, what's next for you? I can't see you sitting around the house.
Well. One of the things is I do need a rest. So I know for at least 1 month, the month of January, I'm going to enjoy winter here if we still have a winter in the state of Maryland. No, I do. I'm going to take a break, but I I still write, and Paul Cosin and I. We're working together. I write papers. I've even written papers while I've been the director of the Weather Service. I wrote this paper on Weather Ready Nation, the COBRA BAMs, to lay out the whole reason for it, what we're doing, the initial success, and where we're going. Loved writing. I just love writing. So I can tell you one thing I want to work on is Volume 3, Northeast Snowstorms of the 21st Century. Paul is back.
You've got something to add now. I mean, obviously.
Yeah. So we got the cases, and there's been a lot that's happened in the winter service area. So, we're going to start thinking in terms of that. But I need a rest. I've been actually, my wife and I. We just celebrated our 50th anniversary.
Wow, congratulations.
She's been with me every step of the way from the university days through this, and we realized that I've been on the go for 50 straight years doing this. Whether it was, I was publishing papers as I did my master's thesis was my first formal publication. I been working papers from even before I had my PhD, worked on national, somehow got involved with what was called Sesame. Don't ask me to explain what Sesame was. And STORM, which was the predecessor of the U.S. Weather Research Program. I was involved with that as a pre-doctoral student. And then got to NASA, and then here it's just been go, right? So need a rest.
Yeah,
and
I can see your wife
that,
insisting on that.
Yeah. And after that, we'll figure it out. But I do want to work on Volume 3. I'm not advertising that we'll actually get it done, but we're going to give it the good old college try. So that'll keep me going.
Yeah. Well, yeah, I'm sure you're going to be showered in accolades over the next few months as your time at the National Weather Service winds down. But let me say on behalf of us in the media, on our end of the process, your work ethic and scientific honesty and dedication have been an inspiration. I mean, I know how much you travel because you're at every conference I'm at, and then you're at 100 more that I'm not at, and the country is much better.
Don't forget the WMO.
Yes, exactly, and then the international aspects of it.
So let me just say, with the WMO, one of the things that we've been promoting, and it's working now in the Caribbean, is weather-ready nations. Plural. Take a look at what's going on down there. They've embraced this. El Salvador's forecast office is now in their emergency operations center. Look what happened last year with the hurricanes that the two one was a Cat 4, one was a 4 going on a 5, slammed into that area.
Nicaragua,
and they lost several hundred lives. When Mitch slammed into that area, they lost 10,000 lives.
Right.
Okay. You don't want to lose one life, but they were ready. They were ready and responding 5 days before landfall on both those back-to-back storms. It was really remarkable. And you got Caribbean countries now that are really spinning up on this weather rating nations. You pay attention to that. It's taken off. We're doing that through the WMO, and I see hope for that in areas like Southeast Asia, some of the island, especially the island nations. We're working on Europe. We saw what happened in Germany this year. They got some work to do in that regard, as far as I'm concerned. But it's yeah. So this is has had a global influence. But yeah, I need a rest and get some recalibration here, and perhaps I will land doing some other things.
Well, the country and the entire worldwide weather enterprise is much better for your time in government. So, Louis, thanks so much for being here, and we can't wait to see what's in your next chapter, because I know there's going to be lots more to come.
Thank you very much. And Bryan and Luke, I certainly appreciate everything you do, and what's involved with it. And Bryan, I think I told you with Andrew, our best friend, who was our best man at our wedding, was under a mattress in his house just southwest of the hurricanes, and the only thing he listened to was your radio broadcast during the storm, and that's all he talked about when I got down there. That's how I first became aware of who you were, was through his testimonials and what he lived through in Andrews. So anyway,
I appreciate that.
Yeah.
And, that was a moment that things came together. It's as you have articulated so well in your time. You make plans. You have a plan, and sometimes, boy, you need every ounce of that plan because Mother Nature comes along and like fills in every gap, right, and takes advantage of every part of your plan. But because you had the plan, you actually can execute.
And one of the things I said to him, because he was also a technology fanatic, I said, don't forget, I said, this Bryan, because he was giving you all the credit for everything, right? I said he was probably using the first NexRad radar, because that was in Melbourne, that was seeing those bands, because you were timing the bands.
Yeah, no, but no. So I'll tell you the story, because we did not have in 1992 access to Melbourne.
No,
we had a microwave feed from the Hurricane Center to get the Miami radar. But one of the parts of our plan was to put in a line to the West Palm Beach radar. If you remember, they bought a radar to fill in the gap in West Palm Beach. The rich people up there put a it was a WSR-57 essentially at the Palm Beach airport. So we had that on dial-up. And meteorologist named Brian Allen, who's the weekend guy that I worked with, he sat there in the weather office for hours dialing and redialing, because the thing would only run for about 8 minutes, and then it would stop and he would redial the phone.
My God, this is great. This is great.
And this is how we knew where. This is how I knew, and the only way I knew was looking at the television. There was no way. I wasn't looking at any machines. I would look at the television and look at the radar, and I went up to the television with a piece of paper with marks on it to say, okay. And I know how far it is. It's 25 miles from Miami to Fort Lauderdale. Now let me compare that to how far it is from this band to the coast. And that was how I was timing the band.
Wow, that's great. That's great.
With the Miami radar, and then eventually the West
Palm.
But the
radar. One of the points that I remember we talked about was your communication was to take action now. Mm-hmm. He said that. So this thing about there's a 15, 30-minute lull in between bands. Mm-hmm. And then just before the next band came in, it was like, take action now, take cover now. Mm-hmm. And he was telling me that, and I was processing that as an action call, which then, Max Mayfield did for Katrina
absolutely.
And a local forecaster as well, down there in New Orleans. And it's those take action statements that really started. We were doing those more holistically after 2011 with the training coming from the social science community. So anyway, it's been it's in a way uh, you probably didn't know that I knew what you were doing.
I didn't know. I didn't know that. We've never talked
Because
about
I
that.
clearly wasn't listening to the weather, on Miami radio or watching it on TV,
Right.
So, but that's where I first heard about what you were doing. So,
Well, well, it's been a pleasure knowing you and seeing your accomplishments, Louis, and we really appreciate having you on here with us today.
okay. Well, thank you very much, and thank you for having me on.
Dr. Louis Uccellini, the director of the National Weather Service. It's going to be odd not having Louis in a leadership position. He's had a remarkable 43-year run in public service. And, all my time that I remember doing the weather, Louis was part of the administration of the National Weather Service. And what an intense job. Louis' schedule is always booked solid, and the fact that he made time for us today is really an honor.
Yeah, it is. And the guy's just incredible. And it's funny how after 50 years of grinding and just doing really intense work and super taxing on the mind, he says, I think I'm going to take a month off. He gets 1 month and then I just know he's going to be back trying to hey, let me in, let me do some work. He's just that kind of guy that's got a deep furnace in his belly that needs to be stoked. So I don't think he's going to be out at the golf course and hitting the links in his retirement. But he's fascinating, and he's done so much, something like 70 peer-reviewed papers, I don't know, maybe even more than that, and so many contributions. He's going to leave some Sasquatch-sized shoes to be filled. But
absolutely.
You mentioned something along in the podcast. You're talking about the GFS and how remarkably good it has done. And not only that, but the Euro, which in years past has been the premier gold standard tropical weather model, has done pretty bad.
It seems like storm after storm. It's now it may be that the high-profile storms have been so much worse or something. You know what I mean? Where if you look at the averages, they're really not that far off. If you look at the overall averages of all the storms. But it just seems like, I found myself, I look at the GFS first, and I used to look at the Euro first before last year. So for hurricane tracking, it really is remarkable. But of course, we should never look at any one model. We should always look at the ensembles and try and understand how uncertain the weather pattern is and all those kinds of things. But yeah, you're right. Really, the GFS, it has been remarkable from a hurricane tracking standpoint.
Is it related to how the simulated vortex is put into the models? I remember we had a storm earlier this year. I don't remember. I think it was Larry. I'm not for sure on that. But there was recon data. So reconnaissance flight went out, and they found the pressure, and a vortex was put into the GFS. The Euro, from my understanding, can't take that recon data and and use that as a starting point to model. So the GFS had a much better forecast, where the European was far too weak. And it was one of the storms that was doing the loop. It was off the East Coast. And I thought it was Larry. Did any of that ring a bell or make any sense?
Well,
Is that incorrect?
I don't know. In my mind, they don't do what's called bogusing anymore. They did bogusing for Hurricane Andrew. That was the big step that allowed back then the AVN, the predecessor to the GFS, to track Hurricane Andrew, is they actually put a false vortex in there because the model had such low resolution that it couldn't resolve a relatively small storm. It was 100 kilometers or some kind of the grid size. So the storm could fall inside the grid. And so they had a way of putting a vortex in there that then would move along with the flow in the model. I don't think they do that anymore. I don't think they've done that for some time because the resolution of the model is so much higher. Now, that doesn't mean that they can't put the data in for a vortex that to better define what the actual data is. But we need somebody that knows models better than I do to answer that definitively, what the difference is between how the GFS handles recon data and how the European handles recon data.
Okay, yeah, that's somewhere in the dusty corners of my brain from
Yeah,
many
me
storms
too.
ago. So who knows? I'll see if I can find where I'd read that.
Well, because one of the things that's happened since COVID is we haven't had the hurricane conferences that we traditionally would have, even though a number of them have been online. So, just it's an interesting change of not having that constant input of the latest thinking in my life and kind of keeping up with what's going on at the same level as I would have before.
Yeah.
So just a reminder, if you're listening to this podcast on your phone, on the podcast app, and you'd like to see a video version, we have that for you at local10.com/hurricane. On the right side of the page, you'll see our last several podcasts, and there you can click for an audio or video version, whichever you like. So for 2021, for Luke Dorris, I'm Bryan Norcross. Stay safe, be well, and celebrate that hurricane season 2021 looks like it's going out with a whimper. Goodbye for now.